This is Ms. Black, and this is Open Campus. This is College Algebra. We are in Module 14. We are on Module 14F now. So in the previous module, we talked about the last curve we're going to graph, which is a parabola. A parabola is a picture of a quadratic equation. And a quadratic equation, our definition from a long time ago in Module 3, was that equation has an x squared in it. We learned there are 4 parts to every parabola. There are the vertex point, the roots, the y-intercept, and the axis symmetry. So what we're going to do today is I'm going to give you an equation that's quadratic, and I'm going to show you how to use that equation to get that information. How do you get the vertex point, the y-intercept, the roots, the axis symmetry, and use that all to draw the sketch. So let's go to the class notes. So if you look here, the first thing that you have to do is understand you're going to have to memorize something. To graph a quadratic equation by just looking at the equation and not doing a lot of work, the equation's got to look in this form. Y equals a, x minus h squared plus k. It is very obvious this is a quadratic equation. There is an x squared. The y is not squared, so we know that it's not a circle, ellipse, or hyperbola. It's not a line because it's not just linear. So when your equation just has the x squared, you know it's going to be a picture of a quadratic equation, which we call a parabola. And a parabola looks like the letter U. And we've seen the most important part or point on a parabola is the vertex point. Well, if you look up there, the h and the k that represented the center of the circle, the ellipse, and the hyperbola, that h and k is going to represent the vertex point of your parabola. So you won't have to do any work. You'll just look at the equation, the parabola, know your vertex point. But look very closely. In front of the h is a negative, a subtraction symbol. And just like with the circle, the ellipse, and the hyperbola, because there was a subtraction symbol in front, you had to change it or give the opposite. So when you give me the h value of the vertex point, it will be the opposite of what you see for h. But if you look at the k value, there isn't a subtraction symbol. There's a plus. Does a plus change a value? No, it doesn't. So the big difference here is when you give me the vertex point for a parabola, the h value you'll make the opposite, the k value will stay the same. That's very easy to remember. The h value is in parentheses, so it's going to become opposite. The k value is not in parentheses. It will stay the same. The other piece to this parabola is a. Look at a. A is in front of x squared. It's connected by multiplication. The number in front of your x squared connected by multiplication was going to tell you something very important about your parabola. It's going to tell you whether your parabola is going to go up, like the letter U, or go upside down. So that A number is not something we're going to put on the graph. It's just going to tell us whether the parabola goes up or down. If A is a positive number, greater than 0, the parabola will go up. If A is a negative number, less than 0, the parabola will go down. Okay? So from the equation of the parabola that I'm going to give you, you'll get the vertex point and you'll know if the parabola goes up or down. Now, you still need to know the x-intercepts and y-intercepts. We're going to find them just like we did with lines. To find the x-intercept, you substitute y is 0. To find the y-intercept, you substitute x is 0. So we're going to take all this information now and graph a parabola. So if you look here at your notes, I have one example. It has many parts to it. So we're going to take this piece by piece. So let's go up to the whiteboard and discuss this equation. All right, let's put it all together. I want you guys to graph a picture of this equation. So the first thing I want you to notice is it has a y and an x squared. It can't be linear. If it was a line, that would be just x, that would just be y. That's out. It can't be a circle, ellipse, or hyperbola because both variables are not squared. It doesn't have both an x squared and a y squared. So when you only have the x squared, you are guaranteed this is a quadratic equation, and that makes a picture of a parabola. This equation is in the form it has to be in the graph. It's in the form y equals a x minus h squared plus k. So when your equation that's quadratic is in this form, which we call standard, we could see three numbers. We could see a number for a number for h, and a number for k. And those three numbers are going to be clues to help us graph the parabola. The first thing you're going to see is a number for a. A is always in front of x squared connected by multiplication. Your a value here is -1. And all that number is good for is to tell you whether you're going to draw your parabola up or down. If a is positive, the parabola goes up. If a is negative, the parabola goes down. So everybody look, your a value is -1. That means when we draw a parabola, it's going to go down. That's important to know which direction you're going to draw it. The other piece of information you'll get out of looking at this equation in standard form is the vertex point. The vertex point is h and k. It's not called the center. Remember, the center of a circle, ellipse, and hyperbola was h and k. The center, there is no center to a parabola. You call it the vertex point. There's an h value and a k value. H is still with x, k is by itself. The h value is going to be the opposite of what you see, because of that minus sign. So the h value is not 3, it's -3. The k value has a plus in front of it. So the k value is going to stay the same. So the k value is 1. That's very easy to remember. If you think about the other three graphs we've done, the circle had the h and k in parentheses. The ellipse had the h and k in parentheses. The hyperbola had the h and k in parentheses. So we took both of those numbers and we made them opposite. With the parabola, only the h is in parentheses. So only the h becomes opposite. The k stays the same. So now think about this. If we know we have this point, which is the vertex point, and we know the parabola is going to go upside down, is this point the max or the min? Well, yeah, it's obviously the highest point. It's the max. If your parabola goes upside down, this vertex point will be the highest point, the max. And then if I want to know the value of it, the value of the max, remember we talked value is the y value. What is the y value of this vertex point? 1. That will be the highest value on the y-axis, 1. So from just being able to look at the equation of the parabola in standard form, we know if the parabola is going to turn up or down by looking at the a value. The a is always in front of x squared. If a is positive, the parabola goes up. If a is negative, the parabola goes down. That's important because when you find that vertex point, I got to know if that vertex point is a max or a min. You don't need a graph. If the parabola goes upside down, that vertex point will be the highest, the max. And its value of the max is the y value, 1. Now, what you will not get by looking at that equation is the y-intercepts or the roots. We're actually going to have to do some work. And think about this. All you know right now is you have a vertex point, -3, 1. You know the parabola is going to turn upside down. But you got a problem. How wide do you make it? Because this is one curve and not two, we don't have any boundary lines to draw in. There are no asymptotes here. So for us to decide how wide to make this parabola, we got to use some other facts that we've already learned. If you think about it, when this parabola turns upside down, it is eventually going to touch the x-axis. So we got to find those roots. We also know as this parabola turns upside down, it's eventually going to cross the y-axis. So we got to find the y-intercept. So that's why when you graph a parabola, besides plotting the vertex point, you actually got to physically plot the y-intercepts and the x-intercepts. Every parabola has one y-intercept. So that's the first point you want to find. To find a y-intercept, we go back to the definition. If you're on the y-axis, your x value's got to be 0. So you're going to take your equation and replace x with 0. So we're going to do some algebra work here. Our equation is y equals negative x plus 3 squared plus 1. To find a y-intercept, you let x be 0. Y equals negative 0 plus 3 squared plus 1. Guys, there's no letters on the left-right side. This is all numbers. We're going to follow order of operations. We're going to do what's inside parentheses first. So we're going to leave the negative. 0 plus 3 is 3 squared plus 1. We're going to do exponents. That square belongs to the 3, so we leave the negative. 3 squared is 9 plus 1. Negative 9 plus 1 is negative 8. Now, just like we did with lines, you do not write a y-intercept as one number. A y-intercept is physically a point you're going to plot. That y-intercept's x value was 0. That's what you substituted in. And the y value is negative 8. So now you have a second point you could plot on your parabola. You would go to the y-axis to negative 8. But look, 2 points are not going to be enough to graph a parabola because you would make a line. So that's why we need more information. Every parabola has a vertex point. You can get it by looking at the equation. Every parabola has a y-intercept. You can always find the y-intercept by replacing x with 0. But those 2 points are not going to be enough. So the next question says, find the coordinates of the roots. Roots is a fancy word for x-intercepts. So we're going to actually have to do some work. So let me erase this. And now here we go. The roots are the x-intercepts. You already learned the definition when we did lines. If you are an x-intercept, you are on the x-axis. If you are on the x-axis, you let y be 0. So we're going to take our equation we were given and replace now y with 0. And you're not going to like this. You actually have to solve that equation. Here we go back to modules 3. How do you solve that equation for x? Well, I would move the 1 over, subtract 1. So I get negative 1 equals negative x plus 3 squared. You can't take this negative and distribute it because you have a square here. So this is the number negative 1. So let's move it because we want to get that square isolated. Negative 1 divided by negative 1 is 1. That equals x plus 3 squared. Ooh, this looks really familiar. How do you get rid of a square? Very good. You square root both sides. We know squares and square roots cancel out. That's going to leave us our x plus 3. What is the square root of 1? Very good. When you stick a square root symbol in an equation, you've got to put both a plus and a minus. That merely means from a blast from the past. We're not solving one equation here, we're solving 2. We have x plus 3 equals 1. X plus 3 equals negative 1. And then we'll solve, we'll subtract 3. X equals negative 2. We'll subtract 3. X equals negative 4. So I know that you're not going to like this because I kind of fibbed a little bit. When we're graphing, we do use a little bit of our solving equations concepts we've learned in the past. When you find the root or the x-intercept of a parabola and you replace y with 0, you are actually solving a quadratic equation. And this quadratic equation was easy to solve by doing the square root method. Now remember, just with lines, when you write the x-intercepts or roots, you've got to write them as points. So you just don't write these numbers, you write them as points. One of the roots, x is negative 2, and what do you use for y? 0. The other root, x is negative 4. What did you use for y? 0. So now watch. This is telling me my parabola is going to touch the x-axis twice. Sure it is. Here's one root, negative 2, 0. Here's the other root, negative 4, 0. Now do you see the curve coming together? Is everybody good with that? Now, we have a problem. Every point on a parabola should have a buddy except for the vertex point. That's the vertex point. Do you see how this point in blue and this point in blue have a buddy? Well, this point down here in purple's got to have a buddy. Now, how do you know how to put that buddy in? Here's where the axis symmetry helps. The axis symmetry is an invisible vertical line that goes through the vertex point. So if you would draw that vertical line in. Now watch. Do you see how here's the vertical line? This point is one away to the right. This point is one away to a left. That's what we mean by symmetrical, the same distance. So now look, this point is 1, 2, 3 from that axis. So its buddy's got to be 1, 2, 3 from its axis. Its buddy's got to be over here. Because for you to make a pretty parabola, every point's got to have a buddy except for the vertex. So if you draw the isosymmetry in, you'll know where to put the buddies. The buddies should be the same distance away. So then you can play connect the dots. Here comes your parabola. Your parabola's got to go through the vertex point, the roots, and the y-intercept. So every parabola should be made with at least 3 points or 5 points. Okay? It should be made with 4. Should be 3 points or 5 points. Now let's answer the last 3 questions. They want to know the equation of the axis symmetry. Well, when you draw it in, it's obvious. It's a vertical line. Vertical lines use the letter x. This touches the x-axis at negative 3. And we said in the previous module, the x value of the axis symmetry is the x value of the vertex point. Now, the last 2 questions have to do with vocabulary words, domain and range. So we're going to have to explain these words. We've heard them before, but let's re-explain them. So let me erase all this work out of your way so we could talk about domain and range. The word domain means x. We've already heard that. Domain means your x values. And the word range means your y values. Now, these words do not mean the same thing as x-intercepts and y-intercepts. Everybody come look at this picture. These 2 points are sitting on the x-axis. They are x-intercepts. This point is sitting on the y-axis. This is a y-intercept. That is not what these words mean. These words have to do with traveling. Okay? When you ask the domain of a picture, a graph, you're asking me to travel the x-axis. And when you travel the x-axis, you move left to right. So I'm asking you, if I look at this whole picture of this parabola, which let me make it a little bit darker so you could see it. I'm asking you, when I say the domain, I'm asking you, how far does it travel to the left and how far does it travel to the right? I am not asking you where it touches the x-axis. Okay? Totally different word. If I asked you where this parabola touched the x-axis, you would say negative 4, 0, negative 2, 0, the x-intercepts. I'm asking you how far it travels. Now, this is a trick question, because a lot of you are going to say, well, it travels from negative 4 to positive 2. Well, if you said that, then you're telling me your parabola is only that big. Your parabola is not this big. It doesn't just go from negative 4 to positive 2. Your parabola is a little bit wider, a little bit wider, a little bit wider. And in fact, if you look, there's arrows on the end, which means as this parabola goes down, it keeps spreading out. It doesn't go down vertically. It spreads out. All of you have a parabola on your body. Your parabola is your legs. That's a curve. And just like a cheerleader doing a split, As you go down, your legs go out. Can't do a split on here. This is a carpet. But I just wanted you all to realize that. That's what's going. See how as I go down, lower, my legs go out. So when I ask you domain, I'm asking you how far to the left and how far to the right would my legs go out? How far to the left and how far to the right will this parabola go? Well, if you look here, this point goes as far as x is -6. But that's not the furthest it goes, because as you go down, it's going out. There's a point here, and x is -7. So if I continue this parabola to draw it, do you realize as I go to the left, these values on x are getting smaller? There is an x value at -8, and there is an x value at -9. So these x values, we're going as far left as we can go. Well, there's no number. That's the concept, negative infinity. You are saying this arrow, as the parabola goes down, it keeps going to the left. It's never going to stop going to the left. When you go to the left of the number line, you're heading towards negative infinity. Now, how far to the right does this parabola go? Well, the same concept. As this parabola goes down, it keeps moving to the right. When you move to the right of the x-axis, the numbers get bigger. They go to positive infinity. And if you remember from modules way ago, this is called interval notation. Do you remember what symbol we put on infinities? Very good, we put parentheses. What that is telling you is when you draw a parabola, because there's arrows, it will constantly open up. It will go all the way to the left and all the way to the right. Well, if you go all the way to the left of the x-axis, you're going to smaller numbers, negative infinity. If you go all the way to the right, you're going to bigger numbers, positive infinity. That will always be the domain of a parabola. If the parabola opened upward and there were arrows, it would go all the way to the left, negative infinity, all the way to the right, positive infinity. Now, the range means the opposite. If domain means to travel the x-axis, range means traveling the y-axis. So when you travel the y-axis, you go from being down to up. So when we talk about range, we're asking how low will the parabola go and how high will the parabola go. Well, that's like the y-axis. So if you look, here's your parabola. Your parabola is the lowest point at -8? No, because it's going to go lower and lower. How low will you go? How low will you go? Well, those arrows keep going down. It's going to go as low as it wants to go. So if you can't stop it from going lower and lower, it's going to approach infinity. Which infinity is that? That's right. That's negative infinity. That's as low as it's going to go. Now, how high is this parabola going to go? Well, guys, there is a high point. There are no arrows that are pointing up. If you follow this parabola, its highest point is right there. That's what you call the max. Well, how high is that? That's as high as +1. So it's real important you understand that. A parabola, because it goes up and down, can have either a low point or a high point. This parabola has a high point, and its y value is at 1. That's going to be the highest point. If you remember from modules ago, when you write interval notation, smaller, bigger. So it's as low as negative infinity. It's going to keep going low, but it's going to hit that high point. Now we need symbols. Infinity always gets parentheses. Because this is an actual point, we put a bracket. So you could tell me the domain and range of every parabola. I could tell you right now, you might as well memorize this fact. The domain of every parabola is going to always be negative infinity to positive infinity. Because the parabola is going to open all the way to the left and right. What's going to be different is the y values, the range. Because this parabola is pointing down, it will go as low as you want, but its high value is here at 1. Now, I will see you in the next module where it's not so easy to look at the equation and get the information.